So we'll go ahead and get started. Now, normally what I do is we'll lecture for about 45 minutes. Then we'll take a short break, come back, do another 45 minutes of lecture time, take a break, come back and do another one. So I usually try to break the class into 3 different parts. So let's go ahead and get started. And we're going to start with Chapter 1. So we're going to look at Chapter 1, and we're going to look at Section 1. Okay, so Chapter 1, Section 1 here. This section should mostly be reviewed. In this section, we're going to be looking at equations, and we're going to compare those to expressions. We'll see what the difference is. Then we're going to learn how to solve equations, and then we'll learn about literal equations, and we'll look at a few applications. So let's go ahead and get started. We need to know some basic definitions. So we need to know the difference between an equation and an expression. So we'll start off with an expression. So an expression has no equal sign. And cannot be solved. Now, it might be able to be simplified, but you can't solve it. So here's some examples of expressions. 3x minus 5. 9x squared minus 7x. How about 8x cubed plus 19? So those are all going to be examples of expressions. Now, we don't work with expressions much in this course. We are going to focus primarily on equations, because equations we're going to be able to solve, okay, and we're going to actually get an answer. So these are expressions. We encounter expressions once in a while, but mostly our focus is going to be on equations. And an equation has an equal sign, and it can be solved. And here's some examples of equations. These are all going to be examples of equations. Now, they can be solved. Okay. We're going to learn how to solve these equations in a moment. We need to know the difference between an equation and an expression. And that has to do with the equal sign. So if you have an equal sign, it's an equation, and you can solve it. And solve just means you get an answer. Now, it might have one solution, it might have an infinite number of solutions, or it may not have any, but it can be solved. An expression, on the other hand, you can't do anything with it. You can simplify it. You might be able to combine like terms, but you can't get an actual answer out. So now that we've looked at the difference between the equations and the expressions, we're going to move on, and we're going to talk now about the 3 types of equations. And the first one is conditional. And for a conditional equation, it can be solved for one answer, or a specific answer. So we're going to be able to solve it, and we're going to get usually a number. What you get on these is going to be a number. Now, you can have more than one answer, but you'll get an actual numbered answer. And so here's an example. How about 3 times x plus 9 equals 15? Now, this should be something you're familiar with. You should already kind of know how to solve this. So, what do? We want to solve it, so that means we get the x by itself. So, order of operations, what do we do first? We need to get rid of our parentheses. So we do that by distributing or pushing through that 3. So that gives you then 3x plus 27 equals 15. And we can move that 27 over to the other side with subtraction. And that should give you then negative 12, right? Watch your signs here. So that's going to be a negative 12. And then how do we finish it out? Well, we finish it out by dividing. So we divide both sides by our 3. And now we have an answer. So now we have the answer when we reduce of x equaling a negative 4. This is conditional. And this is called a conditional equation because we got a specific answer. Okay? Conditional means there's a condition that makes it work. So some number or maybe multiple numbers that make it work, make it come out to be true. Now, this negative 4 is a solution to your equation. And what do I mean by it being a solution? Well, if a number is a solution, I should be able to plug it back in and get the sides to match up. Okay, so if you plugged in negative 4 back into the original, it would be a solution. So this is your solution. Because if you plug it in, the sides should match up. Okay, we can check real quick. Negative 4 plus 9, if I plugged it back in, that would be 5. 5 times 3 is 15. And the other side, the right-hand side, is already what? 15, right? So what makes something a solution? This is negative 4 is a solution because when you plug it back in, the sides match up. So that's a conditional equation. And most of the equations that you encounter are going to be conditional. Now we do have 2 other types that we need to look at. And they are the identity and the contradiction. And we'll start with the identity. So in an identity, the sides are the same. The solution set is all real numbers. Okay, so your solution set here is going to be all real numbers. The way I remember it is I think of what does it mean to be an identical twin? Well, if you have an identical twin, that means they're exactly the same, right? So identity, equate that with identical twins. Sides are the same, twins are the same. Okay, if they come out to be exactly the same, that means your solution set is going to be all real numbers. It's a true statement. Here's an example. They may not look the same at the very beginning, but they are after doing a little bit of manipulation. So here's an example of an identity. About 5 times x plus 3 minus 4 equals 3 times x plus 3. Okay, let me make sure these sides are going to match up here. We'll do a plus 2x, that way those match there. Okay, and then we'll do a plus 2. Okay, so that should make sure that these come out to be the same. Now, let's begin solving this. Well, what do we need to do? We need to first clear out our parentheses, and we do that by using our distributive property. Now, you can skip steps if you would like. Most of the time, though, I work out every single step. That way, if you go back and look at these examples later, you won't get confused about things. But if you're comfortable with things, you can skip through a few steps. Well, let's go ahead and write out what we've got. We've got 5x plus 15 minus 4. That's on the left. On the right-hand side, we have 3x plus 9 plus 2x plus 2. Now, we can work on the left-hand side, and we can break that down, combine like terms, and that's going to be 5x plus 11. On the right-hand side, we have a 3x, a 2x, that makes it a 5x, and 9 plus 2 makes it also an 11. So these sides are the same, so this is called an identity. And your solution is going to be all real numbers. Okay. We're doing some very basic examples at the beginning. And then once we get the 3 types down, then we'll progress on to more difficult questions. We'll look at some that have fractions we have to clear out, and a couple that have decimals as well. But that's your identity. The last one, or last type of equation, is going to be the contradiction. And a contradiction is just a false statement. So we're going to be looking at a false statement. And this has no solution. So the solution is going to be the empty or the null set. How do I remember contradiction and what it means? Well, I think of a court of law, and I think of contradictory testimony. So if I give testimony under oath, and let's say the defense attorney says, you gave contradictory testimony. What does that mean? That means you lied, right? You gave a false statement. A contradiction is the same as that contradictory testimony. You gave a false statement. It has no solutions. It can't be done. So here's an example of a contradiction. 5 times x plus 8 equals 5 times x plus 3. So this is going to be an example of a contradiction. And when we go to solve a contradiction, the variables are going to disappear, and we're going to end up with something that just doesn't make sense. And so we begin by distributing the 5s through, and that gives us 5x plus 40 equals 5x plus 15. Now, when we go to solve this, something special is going to happen. When I move those x's over, they're going to disappear. Okay? And we're going to be left with 2 numbers that can never equal each other. Because when I move those 5x's over, they're going to cancel out. So the 5x's can be moved over, and that leaves you with this. And 40 is not equal to 15, is it? No. So that is a false statement, right? Because 40 cannot equal 15, and that means that this is a contradiction. And the solution set is empty. Now, I do want to cover a few more terms just to make sure we know all the terms from our homework before we proceed on to be solving equations. So we're going to talk quickly about a solution. Again, we talked about this a moment ago. But let's just do a real quick example of checking to see if a number is a solution. So here's one. So is x equals, let's say, 4, a solution to (3x plus 2) equals 14. So I want you to tell me, is this a solution or not? True or false? So is x equals 4 a solution to this equation? How do we check? Well, we just simply plug it in. So we're going to plug in that 4. And we're going to combine everything together. We're going to see how the sides match up, if they do. And if I plug that 4 in, then that gives me, again, 12 plus 2. And then that gives me 14 equals 14. These are the same. So x equals 4 is a solution to 3x plus 2 equals 14. Okay? So there's a couple of questions in your homework. You just say, is this number a solution? And it's a true-false. All you need to do is just simply plug that number into that equation and see if the sides actually match up. Okay, so pretty simple on that one. Another topic we need to talk about is linear. We need to talk about the difference between a linear and a nonlinear equation. Linear equations have only the variable x. So we've got no squares, cubes, or any powers, or roots, and x is not in the denominator of a fraction. Now, what we're going to be looking at today is linear. Next week, we're going to be looking at nonlinear. And if you kind of remember your intermediate algebra course, at the very end of it, we talked about factoring. Right? Remember factoring and working with those polynomials? Those are nonlinear. Okay? Anytime you have a square, you have a cube, you have any power or a root, that's nonlinear. So linear equations are the equations we've already solved, the ones that we're very familiar with. So these are going to be examples of linear. 3x plus 9 equals 12. 8x minus 15 equals 4x. And 9x minus 3 equals 7x plus 4. So those are all examples of linear. No powers, no roots, x is not in the denominator. So those are all linear. Here's examples of nonlinear. These are not linear. So these are going to be examples of nonlinear or not linear equations. 3x squared plus 9x equals 5. That is nonlinear. 4x cubed plus 3 equals 9. Nonlinear. The square root of 2x plus 1 equals 19. Nonlinear. And this is also nonlinear. 8 over x plus 3 equals 2. So those are all examples of things that are not linear, also called nonlinear. So there's only one question in your homework, and it just basically asks, is this linear or is this nonlinear? Well, and I'll just go ahead and look at it and we'll talk about it quickly. So this is the only one you're going to have in your homework. You'll get your homework packet before you leave today. But this one right here, would this be linear or nonlinear? Well, when we look at it, do we have any square roots? No. Do we have any squares or any powers on the x's? No. So this would be an example of a linear equation. Okay? It's linear. What makes something nonlinear would be, again, a square, a cube, a square root, or x is on the bottom of a fraction. Those are nonlinear. Most things are going to be linear in this section. Now, next week, we're going to be discussing nonlinear ones, which means we have to factor. But that's for next week. So now let's work a little bit more with solving our equations. We've talked about the basic terminology. So now we know the three types. We know the difference between an equation and an expression. Okay. We've talked about what's linear, what's nonlinear, and we talked about what are solutions. So now let's just review how to solve these. And I'm going to give you some more difficult questions that involve fractions. Because we do encounter a lot of fractions. And when you have fractions, you really want to keep the fractions. So you do not want to clear out the fractions. You want to keep those fractions. Or not clear out, but turn them into decimals. You want to keep the fractions. Don't turn them into decimals. And when we have fractions, we clear them out. Okay, but we do not use decimals. So let's remember how we would clear out and work with this type of equation. So this is an example of an equation, and this one I believe is going to be conditional. But we're going to have to remember all the different concepts and how to solve this. Now, what I like to do when I have something like this is I like to divide my paper. On the left-hand side, this is going to be my step-by-step work. And I try to keep this as clean and as neat as possible. On the right-hand side, this is my scratch work. So it doesn't have to be as neat as over here. So what we do is we need to go ahead and distribute through that 5 first. And if we forgot how to do that, well, we can do it over on the right-hand side. So when we distribute through, right, we're just going to be writing it out on the right-hand side. So let's work with our first one. So the first part we got 5 times 1/3 x. And if it helps, you can write that 5 as a 5 over 1. The 5 and the 3 can't cancel, so if I multiply across, what do I get? I get 5/3 x there. So that's going to be my first piece, 5/3 x. Do the same thing with the other one. 5, and you can make that 5 over 1 if it helps, times 3/7. Well, again, the 5 and the 7, those can't cancel, so we multiply. 5 times 3 is 15. 1 times 7, that makes it a 7. So now, all of our parentheses are gone. We now need to clear out our fractions. So what do we have for denominators? Well, if we look at our denominators, we have a 3, we have a 7, and we have a 15. What I like to do is I like to work with these 3 denominators in pairs. So let's just take the first 2. So if I just look at my first 2 denominators, let's find the least common denominator of 7 and 3. Well, do 7 and 3, do they have anything in common at all? No. What's the least common denominator of 7 and 3? Well, the least common denominator of 7 and 3 would be 7 times 3, which is 21. Now we need to work with the 5. So now we need the least common denominator of that 21 that we just found and 5. Well, 21 and 5, they have absolutely nothing in common. So the smallest denominator is then going to be 21 times 5, and 21 times 5 makes it then 105. So that's my least common denominator. So work with them in pairs. And once you found your least common denominator, now you've got to multiply. So we know our least common denominator is 105. And so we're going to put our 105 out in front, and we're going to distribute it through each part. And don't worry about the numbers being really large, because we have a calculator. So we don't have to do things mentally. If you doubt yourself, use a calculator. I would rather you use a calculator than make mistakes. So if you're not really good at mental math, not a problem. Just use a calculator. Now, how are these going to work? Well, when we work these out, I think the other calculator is a little bit easier to see. When we work these out, what we do is we divide, right, and we multiply. So we're going to divide by the number down below, multiply by the number on the top. So on our first one, we've got 105. Okay, I don't know the glare's horrible there, but we've got 105. And maybe I can make this a little bit easier to see. Okay, so we've got our 105 there. Hopefully you can kind of see that now. We've got 105. What are we going to do with that? We're going to divide it by 3. So 105 divided by 3. That's 35. And then what do? We divide, and then we multiply by the number on the top. So 35. Then we multiply that by our 5. And that gives us then 175. And we bring our x down. We repeat the process on the next one. 105. We're going to divide that by 7. And I know it's hard to see. Let me make this a little bit darker here so you can kind of see we've got the 15 there. Okay, so we took 105, we divide that by 7. That gave us our 15. And then what do? We multiply that by your 15 on the top. That gives us 225. Next, repeating the process, we take our 105, we divide that by 5, which is 21, multiply by that 1 on the top, and that leaves you then with a 21x. Nothing down below, so we just multiply 105 times 2. That makes it then 210. So what we have now done is we have now successfully cleared out all of our fractions. And now we've got something that we can work with. Now we just use a calculator and solve it. So move things around. We'll move the 21x over. And we'll move the 225 to the right-hand side. So now we've got 175 minus 21. That should then be a 154x. We're going to move that 225 over. So 210 minus 225, that gives you a minus 15. We're going to now divide by 154. And that then leaves us our final answer being x equals now a negative 15 over 154. And we need to check and make sure we can't reduce. Bless you. So 154, we need to see if it has a 3 in it or a 5. It doesn't have a 5, but we'll check for a 3. 3 doesn't go in there either, so this is not going to reduce down any. So we now have our answer. And since we got an answer, this would be conditional. It's going to be conditional because we have an answer. Let's try another equation that involves fractions. This one's going to be a little bit different. Same directions. We're just going to solve these. Now, this brings back another concept that we can use. We need to clear out these fractions. Now, we do need a common denominator in some cases, but this one we can use the technique called cross multiplication because we have a fraction equaling another fraction. Okay? So fraction equaling another fraction, we can cross multiply. So let's remember how we can cross multiply here. It has to be a fraction equaling another fraction. You can directly cross multiply. That's going to save us from having to get the least common denominator. So when we cross multiply, we have 2 times 4x plus 5 equals 3 times 5x plus 9. So we cross multiplied there. That gave us that. And now we've got something that we can work with, and we can very quickly and very easily solve this by just distributing the 2 through and also distributing that 3 through. So we'll do that. So distribute that 2 through and distribute the 3 through. And let's see what we're left with. So we are now left with 8x plus 10 equals 15x plus 27. Simple enough here. Solve it. So let's move that 15x over. I usually like to get the variables on the left. Numbers go to the right. And we'll move that 10 over as well. And we've got 8x minus 15x. Watch the signs. 15 is negative. It's the larger number. So that means my sign's going to be negative. And 15 minus 8, that's a 7. So that's going to be a minus 7x there. The 10s are going to cancel. The 15x's cancel. And 27 minus 10. Okay, 27 minus 10, that makes it a 17 again. Divide by our negative 7. And when we write our answer, we bring that negative up to the top. So that negative here is going to come up to the top. So that would then be a minus 17 over 7. You have an actual answer. So this one would again be conditional. I want to pick a couple of problems from our textbook to look at. Let's see if I can find a good one here. I'll try to do some that are contradictions again, some more that have fractions as well. We're going to look on page 111. And if you don't have your textbook, that's fine. I'll put it up on the screen and write it down. And we're going to look at question 32. So I'll just write that down for us. Page 111, question 32. And what we've got is we've got 1/2 times 6x plus 20 equals x plus 4 plus 2 times x plus 3 here. Okay, so this is another equation that has a fraction in it. Now, the good thing about this one is our fraction is going to disappear. So when we distribute that 1/2 through, it's going to go away. And that's going to be really nice. So we're going to distribute that 1/2 through, and we're also going to distribute the 2 through. And 1/2 of 6, well, 1/2 of 6, that's easy. 1/2 of 6 is a 3, so that's a 3x. 1/2 of 20 is a 10. And then we've got x plus 4. Distribute the 2 through. That gives us then 2x, distributing through, plus 6. Now we can see that this is going to be different from the previous questions and previous equations, because when I work on the right-hand side, I have 3x total, and 4 and 6 makes it 10. And notice these are now the same. So once the sides match up, what is this? This is an identity. And what's your solution going to be? All real numbers. So this one would be an identity. And again, your solution set is all real numbers. I do want to do one more of these. Now this one's not going to have a fraction in it. This one's going to have square brackets. So just so we remember how we work through and handle questions that have square brackets. Let's look now at question 20. This is on page 110. I'm kind of skipping around because that's how your homework is going to be. We're all kind of skipping around. So we're going to look at question 20. And you'll see something very, very similar to this in your homework. And this is on the previous page, on page 110. And we have square brackets. Now, square brackets are used when we already have parentheses being used, because it gets too confusing if we use multiple sets of parentheses. So in this case, we're going to use square brackets. And when we use our square brackets with the parentheses, we always try to work from the inside and we work our way out. So always start in the middle and just slowly work your way out. So in this case, what we've got is we've got some parentheses and they're inside. So the first thing I need to do, and I always like to circle the negatives, that way we don't make a mistake and lose them, is we've got a negative in front of our parentheses. So let's go ahead and just distribute that negative through. And now we've got a 2x, and then we've got a minus 3. Negative and negative makes that a positive x. And then we've got our 5. And those are all still inside the square bracket. Let's go ahead now and clean this up a bit. Inside the square bracket, these can go together, and that makes it then 3x. These can go together, and that makes that then, watch your signs, minus 3 plus 5. Well, that gives you a positive 2. Is everyone all right with that so far? So we just work on the inside, we work our way out, get rid of the parentheses first. Now, what do we do with our square bracket? Well, a square bracket works exactly the same as parentheses, so that 4, we just distribute or we push it through. And that gives you then 4 times 3, which is a 12x. 4 times 2, that's an 8. And the other side is a minus 6x, minus 28. We'll go ahead and work with this. So I like to, again, get all the x's on the left. Numbers go to the right. So I'm going to move that 6x over with addition. and move the 8 over with subtraction. So 12 and 6, that makes it an 18x. On the other side, we have a minus 28 and a minus 8. That should make it, what, a minus 36. Let's double check. Minus 36 here. And then what do we need to do to solve this and finish it out? Yep, divide. And I think it'll go in evenly. I believe that should be 2 if memory serves. So we've got 36. We're going to divide that by 2. And that comes out to then be, watch your negative, single negative, comes out to just be a negative 2. So whenever you have square brackets and parentheses, work on the inside and just work your way out. We've got a little bit more to cover before we take a short break. We're going to talk quickly about literal equations and how these work. Then we'll take a short break, come back, and finish up this section and move on to the next one. Now, a literal equation is simply an equation that has more than one variable. So on literal equations, you're going to be having more than one variable. Now, I'm going to specifically tell you which variable I want you to solve for. So let's do 2 of these, and then we'll take a short break. Literal equations in this section are not that difficult to work with, but I have to tell you specifically which variable I want you to solve for. So these are going to be our formulas. So let's say I give you this. And this is the formula for the area of a triangle. And so I want you to solve it for b, little b. And the first thing I do is I want to go ahead and get rid of the fractions. And so there's a 2 down below. So I'm just simply going to multiply a 2 through. That'll clear out my fractions. And 2 times a, that makes it a 2a. And then the 2 and the 1/2, well, those cancel. And that gives you a bh. We're almost done. Literal equations are not difficult at all to solve through and work with. So now I've cleared out my fractions. Now let's see what we want to do. Our directions say, solve this for the little b. So we find the little b. And then we think about it in terms of opposites. How does the little b relate to the h? Well, the little b relates to the h by multiplication. And we know opposite of multiplication is division. So now we want to solve it for b. And so we get rid of that h by dividing. And that gives you then, I like to write the variable on the left, b equals now, those can cancel, 2 capital A over h. And that's it. That's all that you need to do. The most common literal equations that you're going to encounter are going to be solving for y. And we're going to do these a lot when we go to graph. So this again is a literal equation, and I want you to solve for the variable y. And I'm sure you've done this before, because this right now is what's called standard form. And we'll learn more about this when we graph equations. There's two ways that we can write equations when we go to graph them. We can write them in standard form, which this is, or you can write them in what's called slope-intercept. And if you remember, to get this in slope-intercept, what do we need to do? Well, we solve for y. So what do? We move the 8x over. And then how do we finish it? How do we solve it for y? Well, we simply divide every part by a 7. And now we have successfully solved this linear equation for y. And so now we've got y equals negative 8/7 x plus 3/7. And there's your answer. And this would be in what's called slope-intercept form. And we're going to learn about that in the next chapter. That's in graphing, though. But it all builds upon itself. And you probably have done this before in previous courses. So let's now go ahead and take a short break. And let's meet back here at 9:50. So we'll meet back at 9:50. And we'll finish up this section and start 1, 2 as well.